Hello everyone, and welcome to our webinar on TwinCAT 3 target for MATLAB Simulink. My name is Fabian and I'm in the TwinCAT product manager team. If you have any questions during the webinar, please use the questions window provided by the webinar software. We will try to answer as many questions as possible at the end of the webinar. Okay, let's start. You may know that we already have a webinar online in our archive about the TE1400, which is the product number of the target for MATLAB Simulink. Therefore, I only want to give a short introduction about the product and want to dive a little bit more into technical details, and also want to show you how to work with the generated TCCOM modules in TwinCAT. Therefore, I want to give a very short introduction and motivation why we have this product, and then I will go over to the technical introduction of the TE1400 to give you a short impression on the technical background. Then I will show you a little bit on how to work with our TwinCAT 3 block diagram. Then I want to show you that you can use our automation interface out of MATLAB. Then I will show you how you work with TCCOM and especially with the TC interfaces tab in Simulink, and I will show you some possibilities of our PLC wrapper. And I will close with multitask modules and how we handle these and give a short summary. Short motivation slide. On the top you see our engineering environment, so we provide the possibility to code in IC 61131. Also, we can code in C++ inside TwinCAT, and now we want to focus on the workflow, how we get Simulink modules using the Simulink coder and the Microsoft C compiler into our runtime. The community of MATLAB and Simulink users rapidly grows out there. There are very successful products provided by the MathWorks, and Simulink provides a very great variety of different toolboxes for different applications that you can use to accelerate your development. And further, the model-based design process is more and more important out there for especially complex applications. And also we see that there are some industry-specific applications which are very focused on Simulink development or model-based design processes, like the wind industry, for example, or renewables. And we provide a seamless integration of your Simulink models into TwinCAT 3 and enable those models to be executed in real time, and we give access to the complete TwinCAT ecosystem, providing different interfaces. How to? So this is the first introduction. Left-hand side Simulink, right-hand side TwinCAT. What you can do is to go to the configuration, choose a fixed step solver, click browse under code generation, select TwinCAT TLC as target, and we provide different properties. We will close this and leave it as default. The only thing that we need to do is go to build, have a look on the diagnostic view, and see what's happening. So first we provide the information on the versions, and here we can see that we already have a Visual Studio project. This is the complete C++ project, and here we see that we are building with the Microsoft Visual C compiler, and now we can instantiate the compiled TCCOM object. Now we can go over to TwinCAT, go to TCCOM, say add new item, select the build TCCOM object. Here we are, have a look on the block diagram, attach a task, and go to context and say this is the task that I want to use for this module. Activate the configuration, and we are done. So, everything clear? Okay, let's stop here the webinar. No, of course not. So this is the workflow in general. Start with Simulink, click build, load the build TCCOM object in TwinCAT, and just use it. And to give you an impression on what's happening behind the scenes, I want to go over to this slide from Simulink to TCCOM. The requirements, first of all, are that you have a MATLAB Simulink installed on your system, version larger than 2010A, and we need the Simulink coder, which needs the MATLAB coder. Those are software packages provided by MathWorks. Then we need TwinCAT 3, of course, and the TE1400, which is a separate setup provided by Beckhoff. And we need Visual Studio, larger than 2010, professional, ultimate, premium, whatever. The shell is not sufficient at that point. And then the process is that we can get this C code provided by the Simulink coder. We add our TCCOM framework around this C code, and we build, using the Visual Studio C compiler, binaries. And the result then is a complete build TCCOM, which consists basically out of a sys driver and a TMC file, which is a TwinCAT module class description file. And from these binaries, we don't need any more MATLAB or full Visual Studio. From here we can use TwinCAT only, if we like. Let's have a look on the generated files a little bit. So in the publish directory, so publish means the build binaries. By default, they are located in the TwinCAT folder under 3.1 custom config modules, and here is the model name. And in this folder you can find the TMC file, so the description file for the TwinCAT module class. And this folders here you could see the sys drivers, and if you build a debug driver, the debug information files. The module info XML file provides you information about the block diagram, for example, and the PLC Open POU XML is a description file for the PLC wrapper that we provide. In the build directory, which is the active MATLAB path that you have selected while you click build in Simulink, there we provide the complete Visual Studio project that you can open and have a look at. So all C++ and header files are contained in this Visual Studio project. There you can also find the publish log txt file, which is very helpful if you have support requests. Please provide at least the publish log. Better, of course, is to provide the Visual Studio project or the Simulink model. With the files in the publish directory, so the binary files, these are for instantiation and the usage of TCCOM objects, and everything in the build directory are essential resource files for debugging, report, publishing of TCCOM, and so on. And so here's some workflow that you may have in your company. Of course, there are some automation guys who know lots about TwinCAT, and there may be one or more MATLAB engineers that you have, and those need to have the Visual Studio, the TE1400, all the MATLAB and Simulink licenses, and they can convert Simulink models into TwinCAT objects. And then you can copy those files, everything in the published directory, to the automation guys. And they can then use, without having Simulink, without having a full Visual Studio, only by having TwinCAT, they can use those files and use those models in their TwinCAT solution. Okay, having said that, we can have a look on the block diagram. So the block diagram is one of our most important features because it provides you transparency of the build TCCOM objects while you are in TwinCAT. So we don't have a black box model, we have a transparent model with more or less the same information content that is provided by Simulink itself. But the engineer who is building the TCCOM objects can configure the information content. Having a look in Simulink under TC Advanced, here in the red box, you can see many different properties to configure the information content that is provided by the block diagram. You can also uncheck export block diagram, that those who use the TCCOM object don't see the block diagram anymore. And another feature is that you can integrate this block diagram into your own visualization. Features of the block diagram is view and scope signals, view change parameters, and also browse into submodels that I can show you here. So go to the signals, drag, drop, and we will open a small scoping window to have a look on the signal. You can also dive into submodels and go back again. And everywhere on these boxes where we provide this yellow rectangle, you can change parameters, for example, the P gain or the I gain. So we change, we have prepared values, and now we download those parameters into the real time. You can also say, I not only want to download those parameters as online values, I also want to set the startup values, so you can provide different startup values for the instance of the TCCOM object. For example, the MATLAB engineer said, I want to have a P gain at 50, and you say, okay, no, this doesn't fit to my application. I want to have 45, and you can set it as startup value, and then the TCCOM object will always at startup directly have the 45. Debugging, very important also. So you get the TCCOM object, you do an instance or multiple instances of this object, and you may face some problems. So you want to do debugging. This is of course also possible with breakpoints. If you have the C++ code, which is provided with the Visual Studio project, so you need to enable the C++ debugger, go to the module and attach to the process, in this case by pressing F5. Now I'm starting the project, and now I go to attach to the process, and we provide those breakpoints. If you go to the breakpoint and click expand, you can also see the C code that is lying behind. If I go to the breakpoint, click on the breakpoint, I directly get a hit to this breakpoint, and I will jump into the C code, and you can see this is exactly the line where I end up in my C code. And now I can go step by step through my C code, and of course I can also have a look on the signal values because they are still highlighted in the block diagram. So very huge possibilities in our binaries because we also provide the C++ project. Okay, let's have a look on the automation interface. Maybe you already know the automation interface. The automation interface is, well, it's a COM class, and you can code it out of multiple programming languages. The main focus in our documentation is .NET and PowerShell, but of course you can also use the COM interface out of MATLAB. The automation interface is a programming interface to manage and create complete TwinCAT 3 configurations. So basically everything that you can click in TwinCAT, you can code, which reduces engineering costs by automating time-consuming tasks. And the best of it is that it's available for free. If you have a TwinCAT 3 engineering environment installed on your system, you also have a registered TCAT sysmanager library in your GUC, and which you can use out of MATLAB. So the documentation is full of samples and code snippets. It's a very well documented API, which you can use out of MATLAB. And what I show here is just an example how to use it. This example will also be provided in the information system in a few weeks. If you want to have it quicker, please let me know. I can provide you the sample. On the left-hand side is a window where I just use the class that I've written on. Here is on the right-hand side is a class with multiple methods like create a new Visual Studio instance or link variables. Let's have a look what's happening if I play the video. So here is the constructor of this class, and when I click run, I have a look on the installed Visual Studio instances. I create a new Visual Studio and create a new TwinCAT solution. And in the background you can already see that TwinCAT is opening. Here I create two TCCOM objects, then I link those TCCOM objects and I save the solution and activate everything. And here on the right hand side you can see blank code that you can read, that you can extend. And here in the Visual Studio you can see under System, by magic, there appear two TCCOM objects that are running, so TwinCAT is in green, and they're also linked to each other, so everything done without having touched TwinCAT. The idea of the automation interface with MATLAB is that you may have multiple engineers that are used to use MATLAB and Simulink, but that are not very familiar with TwinCAT, and so they can also stay in their environment and just code everything in MATLAB. So like instantiate those TCCOM objects, activate, link. You can also scan the EtherCAT master tree. This is also a function that I provide here with a sample. Yeah, just download it when it's online and have a look, give feedback. Okay, let's go to another topic, working with TC interfaces. In Simulink under code generation we have this tab TC interfaces, and I want to give some introduction into this tab because it's very powerful. And what we provide here is we have different areas. For example, the inputs, the outputs, we have the parameters, we have the block I/O. The block I/O means that these are those signals who go into a block and go out, for example, in the gain block, inputs, outputs of those blocks. We also have the constant state and the dework, and you can configure all these interfaces. We distinguish here between ADS access and the process image. ADS access is quite simple. You can give access, read only or read write. Depends on the area. And you can say no ADS access. You can say, okay, I give ADS access, but no symbols are generated. Then you need to provide the index group, index offset, if you want to access those parameters or variables. And you can also, of course, say create symbols. And then you can browse by symbols, for example, using the target browser. Keep in mind that these settings affect the possibilities that are provided with the TwinCAT block diagram, because this is a simple ADS client in the background. And of course, this will also affect all other ADS clients that you have in real time or non-real time. Let's have a look on the process image tab, all these possibilities that you have here. In this example, I will go through different settings for the parameter access. So for example, you can define the model parameters as internal data area. Internal data area is the default for all groups, but not for, of course, inputs and outputs. So parameters by default is an internal data area, which means that in the system manager, like you can see here, the data area is not visible. But if you have a look on the parameter tab of the object, you can see how here is a data area called model parameters. You can access, for example, this data area with the PLC wrappers that we will have a look at afterwards. You can also say, I want to have the parameters as an input destination area, like the general inputs of the module. Then you can see the model parameters in the system manager. So the same representation like the inputs. And you can map then with fitting output sources of other modules to the model parameters. You can map the complete structure if you like, or you can map only sub-items, and only those mapped items will be updated, but of course they will be updated cyclically. What you can also do is you can configure the parameters as standard data area. Standard data area means that you can give access to those parameters via a data pointer of another TCCOM object, and you can access this data area at module runtime. It's also visible in the system manager, and well, it's a direct memory access over data pointers, so take care when you use data pointers at runtime that you have consistent data. We also provide the possibility to use a retained data area, which is basically for capturing and restoring data on spontaneous or ordered restart. We store then we cyclically store the data in the retained data area in a NOF-RAM of the device, and the NOF-RAM you need to configure in the IO tree. Have a look on this. Here is the device under IO. Here is the NOF-RAM. Under NOF-RAM you can configure retained data handler, and then you can link the retained data handler to the retained source, which is the retained data area, in this case the model parameters. Okay, let's go over to the PLC wrapper. In Simulink under TC Advanced you have the possibility to select different kinds of PLC function blocks, what we call PLC wrapper or TCOM wrapper. There are basically three different types. So the generic FB, module-specific FB, and the module-specific FB without properties for all parameters. The generic FB is provided with all options, and the module-specific FBs are a little bit simpler to use. So the generic FB is can be used for all TCCOM objects. The module-specific FBs provide much better. So it's much simpler to use because we provide different methods that you can directly get the inputs. So all data types are directly in there. So much easier to use. We can have a look afterwards in the code. The PLC wrapper itself is provided as PLC OpenXML that you can import in TwinCAT 3 PLC. So as you can see here, so in the PLC you just right click and say import PLC OpenXML. You can browse into the publish area, select the PLC OpenXML of the module, and that's it. The usage is, for example, or the benefit is that you can do a function call out of the PLC. So you write something into this TCCOM, you execute your model, you get the outputs, and within the same PLC cycle you can do something else. For example, you can use the provided interfaces out of the PLC, for example, the NC. Or you can call multiple modules within a single cycle, or you can also write some simple PLC code to decide if you want to call this module or not, or maybe another module. Referencing a module instance is also simple, so you have the possibility to do a static referencing. So in this case you have an instance of the TCCOM, so you go to System, TCCOM, Add New Item, and you have an instance, and you only need to provide the reference ID, or the object ID of this TCCOM object. And in the code, you just say, okay, if I'm in op mode, I write the inputs, I execute the model, and I read out the outputs, and that's it. A little bit more code if you want to do dynamic referencing. In this case, you don't have an instance of the TCCOM object, so you provide OID equals 0. In the background, you need to have the class factory loaded of this module. So the class factory can be found under System, TCCOM, and then class factory. So you only need to check the checkbox for the TCCOM object, in this case, simple temperature controller. And the code is just a little bit more here, some initialization settings of the module. So everything that you click by hand when you do the instantiation of the module, you need to code here. Of course, you need to set a task ID, or you need to say set the task cycle time. You need to say this module is called by a module. And once you after the initialization, you can turn to up mode. So you say, okay, state, go to up mode. And when I'm in up mode and there's no error, then it's the same like with static referencing. Write inputs, execute, read outputs, and you're done. Okay, next topic is multitask modules. In Simulink, you can have models with multiple sample times. For example, like in this example here, you have buffer or unbuffer blocks in the when you use the DSP Systems toolbox for signal processing. Or you have a rate transition block, which is a more basic block in Simulink. The only thing that you need to do is go to Simulink, and in the configuration, you go to the solver tab and enable multitasking. So the exact naming is treat each discrete rate as separate task. if you check this, you don't need to set other options or TwinCAT specific options. This is an option provided by MathWorks. And we directly generate a TCCOM object with multiple task contexts. The only thing that you need to consider is that those tasks need to be set on one core, one single core. So for example, in this example here, we have 3 different sample times. So here's, the red one is 1 millisecond. Here is a buffer object because we want to calculate an FFT here. So in this case, here is a second time context. Here is another buffer. Here is a median, and with another time context. So we have 3 different sample times, and we directly, only by checking this box, generate an object with 3 different contexts. Okay, so to sum up a little bit, all Simulink models that you have seen in this presentation are free of Beckhoff specific blocks. So this means that we can that the Simulink model itself is hardware independent, so you don't make your model by integrating some Beckhoff specific blocks hardware dependent. And what we also have is that if you want to change the mapping of inputs and outputs in TwinCAT, you don't need to do a recompile. If you need to specify the mapping in Simulink, then every time you would need to do a recompile of the model because you just want to map the outputs or inputs to another output or input source. We also, with this, can provide multiple instantiation of the same TCCOM object in one TwinCAT configuration. If you have the mappings already defined in Simulink, of course you can only do one instantiation. If this is free and you do the mapping afterwards, you can use the same model multiple times in one solution. We also provide the graphical representation of the model in TwinCAT 3, what you can use for online monitoring of parameters and signals. You can do online change of parameters, change also the startup values. You can debug in using this graphical representation with breakpoints. And what we also have seen is that you can call Simulink models out of a task by setting the modules in a task context, or you can call the model out of other modules. In this case, we've shown using the PLC wrapper how you can call the TCCOM object out of the PLC. Of course, you can also call a TCCOM object generated out of Simulink using a C++ coded TCCOM object. You can also change this without a new compile. So if the MATLAB engineer decided this module should be called out of a module, you can afterwards just say, I don't want to use it out of the PLC or C++. I want to set it into a task context. This can be changed afterwards in the instantiation of the object. And of course, like we've seen, we generate out of the box PLC function blocks, the PLC wrapper. And they provide you the possibility to configure data access to the process image, to the parameters, internal variables of the models by mappings or ADS. So all these things that we have seen under TC interfaces. Something new that we provide in the future, we are currently working on the TE1401, which is the target for MATLAB. The T1401 will use the MATLAB coder to generate TCCOM object out of MATLAB code. approximately we'll have a beta phase in the first quarter of 2019. Yeah, and if you have any applications for this new product, yeah, write me an email, discuss with us or my colleagues your application to ensure that we meet your requirements that you may have to the MATLAB coder or the target for MATLAB. Yeah, maybe we can directly yeah, implement your specifications into the product. So that's the end of the webinar, and I also want to invite you, before I forget this, in 2 weeks we will have another webinar about the TE1410, which is the interface for MATLAB Simulink. So everything around ADS communication from MATLAB Simulink to TwinCAT. And yeah, now I'm happy to answer some of your questions. Okay. So one question is it possible to call existing PLC code from the Simulink model? Today I need to say no. Only the other way around. So we can only call from the PLC the TCCOM objects. The other way around would be great to have, but yeah, may need some very huge work behind the scenes. We have another question. Why could we not see all lines in generated block diagram as blue line? Yeah, this is a good question. We face this question quite often. The answer is quite simple. We can only show those signals that are provided in the C code by a variable. Sometimes the Simulink coder optimizes the code behind in that way that the signal is not represented anymore as a variable. And then we cannot show this signal in the block diagram. If this is the case and you need this signal for debugging purposes or for monitoring purposes in the TwinCAT block diagram, you can go to Simulink and you only need to set a test point to this specific signal. And once you did this, so providing a test point is something that is provided by MathWorks, so it's not something specific by Beckhoff. Then the optimization will be that way that the signal is still visible in the block diagram. Okay, so there is another question on, are there any block library limitations? Okay, so limitations regarding for example, the toolboxes, I think. So basically, everything that can be converted into C code with some exclusions, can be converted into a TCCOM. So if you have a look on the toolboxes in the MathWorks documentation, you can always find a hint if this toolbox or this function of this toolbox is supported by the Simulink coder. And once this is supported, then in most cases this is also supported by TwinCAT. Limitation, for example, is if you have a direct file access. So, for example, the read from file or write to file blocks. So we are working in the kernel mode, and from this kernel mode you don't have direct access to the file system. Therefore, we need to provide some workarounds. For example, for the to-file block, we have an extension block in TwinCAT that you can still use the to-file block, and we then write the files from the kernel mode to the file system. But for example, there are some toolboxes from the MathWorks who consists of user mode drivers for specific hardware. And of course, this cannot be used directly out of our kernel mode. So, but we have some hints on those limitations in the information system on the documentation of T1400 under the FAQ. So if you want to have a quick look on that, so those limitations are well documented in this area. Okay, so are there any more questions out there? If this is not the case, I thank you very much again for having this nice discussion, and I'm looking forward to see you maybe in end of November on the SPS IPC Drives Fair in Nuremberg, or maybe beginning of next year in Hanover. Thank you very much, and bye-bye. Matt is